All right, now we're going to focus on special right triangles, and we're going to do a quick little introduction to it. We've done a handful of special right triangles in class already. One of the most common ones you'll see is a 3, 4, 5 special right triangle. If you did 3 squared plus 4 squared, you would get 5 squared every single time. So we kind of consider this to be one of our basic special right triangles. You'll see different variations on it. We talked about in class that you might go ahead and double all of the side lengths of the triangle and end up with 6, 8, 10. 6, 8, 10. A couple of you guys tried to use that for one of your Pythagorean triples, and I said that that would not work because it is just a 3, 4, 5 that was doubled, right? If you double 3, if you double 4, if you double 5, it'll still end up as that 6, 8, 10 triangle. So we're going to kind of focus on a couple new ones today. But before we do that, let's really kind of look at why the 3, 4, 5 triangle is very useful to us. So if you had one side 33, one side 55, and another side as x, and we were trying to identify what x equaled, we could use the idea of that 3, 4, 5 and set up some proportions to go ahead and solve for it. So if you're able to identify that a length is a variation of 3, and the other leg is a variation of 4, and the hypotenuse is a variation of 5, you can rewrite the problem out as pattern divided by problem. So 3 kind of corresponds with 33 in our problem, 4 kind of corresponds with x, and 5 corresponds with 55 in our specific problem. Now as soon as you have that, you have basically your scale ratio. You have different proportions that we can now go ahead and solve for x. You could do 3 over 33 equals 4 over x to solve for it, or 5 over 55 equals 4 over x. We want to set these up in terms of how your pattern specifically relates to the problem that's in hand. Now as soon as we do these 30, 60, 90, and the 45, 45, 90s, you'll see a little bit more what I'm talking about. So when we talk about special right triangles, normally 3, 4, 5 is not one that you talk about because it's a triple. It's not one of these that fits this this new unique pattern that we're going to use. And we'll talk about the two types that we're going to really focus on today. We've got 45, 45, 90 special right triangles, and then you also have 30, 60, 90. Now 45, 45, 90 specifically talks about the degrees. So if you ever hear a 45, 45, 90, we're talking about a triangle that has two angles that are 45 degrees and one angle that's a right angle. And then likewise 30, 60, 90 means that you have a 30 degree angle, a 60 degree angle, and a 90 degree angle. Now in the 45, 45, 90, we always talk about the side lengths that are opposite those angle measurements. So opposite the 45 is going to be a 1. Opposite the other 45, it's an isosceles triangle. So if you have two base angles, your legs are going to be congruent, so that's also going to be a 1. And then if you did Pythagorean theorem to find your third side, right, 1 squared plus 1 squared equals x squared, and you can kind of calculate it all out, you would end up getting that the hypotenuse is equal to the square root of 2. So just like 3, 4, 5 is a special right triangle, 1, 1 square root 2 is also a special right triangle, but it's unique to the 45, 45, 90s. In our 30, 60, 90s, it's a slightly different pattern. Across from 30 is a 1. Across from 60 is square root of 3. And across from 90, or your hypotenuse, is going to be a 2. You guys must memorize these two patterns. There's no question about it. You need to do this. You will not be given these patterns. You guys will have to memorize them. So let's look at an example of the 45, 45, 90. Now if you see in the pattern up at the top, I've got the 45, 45, 90 right triangle, and I have an n, and an n square root 2. A lot of times you'll see that written out as the pattern, but we're going to go ahead and replace it. Instead of an n, we're going to use a 1. So instead of n root 2, we'll use 1, 1 square root of 2. Right, that's the pattern we're going to follow for all these problems. So in the first problem, we're going to go ahead and identify our different side lengths. So across from 45 is a 1. Across from your 90 is a square root of 2, and across from your other 45 is a 1. Now next, what I'm going to go ahead and do is I'm going to write out my pattern for the 45, 45, 90. The 45, 45, 90s always follow the pattern 1, 1, square root 2. Now, we want to match them up with the corresponding sides. So with my first 1, the 9 corresponds to it. With my second one, it's kind of blank, so we'll just leave it blank. And then the square root of 2 corresponds with the h. Now, that middle one I don't really need, so we'll get rid of it. And we'll throw an equal sign because those corresponding sides are all equal to each other. And we've got a problem that now we can solve for h. We're going to go ahead and cross multiply. We've got 1 times h equals 1h. And 9 times square root of 2 is just 9 root 2. Which means h equals 9 root 2. And we're done. These 45, 45, 90s and the 30, 60, 90s allow us to go ahead and calculate side measurements for right triangles in which we only know one side. Right? If we were just trying to use Pythagorean theorem on that, we would not have been able to do it because you only knew one side. So these 45, 45, 90s allow us to go ahead and calculate sides when we only know one side measurement. Let's go ahead and look at number 2. Same thing, you're only given one side and you're asked to find another. So you can't just do straight Pythagorean theorem, you got to end up using something different. And in this case, they give us one angle as a 45-degree angle, which means the other angle has to be. And now we can go ahead and strike our pattern for it. Across from 45 is a 1, across from the other 45 is a 1, and then your hypotenuse is a square root of 2. So we're going to write out our pattern, 1, 1, then root 2. And we want to list off the corresponding sides. So the side in the problem, so the 1, 1, root 2 is your pattern, and then underneath it is going to be the problem. So 2 root 2 corresponds with my side measurement, that's a 1. And x corresponds with the hypotenuse, or the square root of 2. We can get rid of the other one that we didn't really need. And there's our cross multiplication problem. So we cross multiply, we get 1 times x is just x, and 2 root 2 times root 2 can be simplified into 2 times square root of 4, which is really just 2 times 2, which means x equals 4. And that's kind of how we would use the 45, 45, 90s if you're given a leg and you're asked to find the hypotenuse. All right, let's look at another example of the 45, 45, 90s, and this time around we're given a hypotenuse and we're actually asked to find the leg measurements. Now if they just gave you this problem, you can't really do too much with it unless you wanted to use Pythagorean theorem, I guess, and you could go about doing that. But I think the 45, 45, 90 rules are going to be a little quicker for us. Now, based on the fact that it's an isosceles triangle, you have 2 congruent legs. You also know you have 2 congruent angles. And the only angle measurements that those could be then are going to be 45 degrees. So as soon as I've established that it's a 45, 45, 90, I can go ahead and write out my pattern. My pattern is 1, 1, root 2. And it's always pattern divided by problem. So my 1 is a leg, my x is a leg. My 1 is a leg, I don't know the other leg, so we'll leave it as a question mark. And my root 2 is the hypotenuse. And in this problem, my 6 is the hypotenuse. So my root 2 will correspond with the 6. Again, pattern divided by problem. And pattern we mean 1, 1, root 2, and the problem was x, question mark, 6. So we've got our cross multiplication problem we can solve. This one's going to be a little trickier. We get 1 times 6 is 6, and x times root 2 is x root 2. Now the only reason I said this is going to be a little trickier is because when you go ahead and try to solve for x, you're going to divide by the square root of 2. That shouldn't be too hard. Those will cancel. Right, if we did x root 2 divided by root 2, those cancel. But now we're going to take the 6 and divide that by root 2, and now our answer looks like x equals 6 over root 2. Which you can't have. We talked about this last week. Right? You have to get rid of the square root in the bottom. in the denominator. So we're going to go ahead and rationalize the denominator. And we'll do that by multiplying the numerator and denominator by the square root of 2. If we simplify that, we end up with 6 root 2 over root 2 times root 2, which is just really 2. And we can go back now and simplify our fraction. And we're left with x equals 3 root 2. That's how you would solve for x in a 45-45-90 when you're given the hypotenuse and asked to find a leg. Let's go ahead now and look at the 30-60-90s. Again, I wrote out the pattern how you sometimes might see it with the n root 3, and 2n. But we're going to go ahead and get rid of that stuff and leave it as a 1, a root 3, and just a regular 2. So 1 root 3, 2. In problem number 4, we're given a 30-degree angle, a 90-degree angle, which means the other angle has to be 60, so it's going to follow my pattern. Across from 30 is a 1. Across from 60 is a square root of 3. And across from 90 is a 2. Now what you might be able to do off of this is just go ahead and say, oh, wait a second, I see what the pattern is. I just have to multiply every side by 4, right? Because your hypotenuse is 2, but in the problem it's 8. So if you multiplied every leg by 4, we'll end up getting the right answer. So we can kind of go back and just double check those at the end, but we'll actually go through the process on this. So we're going to go ahead and write out our pattern. And our pattern is 1 root 3, 2. And then underneath it, we're going to go ahead and write out our corresponding side lengths given the problem. So 1 corresponds with x, root 3 with y, and 2 with 8. Now the 2 over 8, that's kind of our scale factor for this problem. That's the one that we really like, so we're going to go ahead and use that to set up 2 separate proportions and solve them both. So 2 over 8 equals 1 over x. You guys can cross multiply that pretty quickly. We'll end up getting x equals 4. And then the 2 over 8 equals root 3 over y. Cross multiply that one. And we'll end up with 2y equals 8 times square root of 3. Divide each side by 2. And we'll end up with y equals 4 root 3. Which is what we said the answer should be from the very beginning, because we were able to identify from the problem that all we had to do is multiply all of our side lengths by 4. All right, let's take a peek at another one here. This one's going to be a little trickier. We know that we have a 60-degree angle, a 90, so it's going to be a 30-60-90 right triangle. We're going to go ahead and write out our pattern. Our pattern for the 30-60-90s is 1 root 3, 2. And the side that corresponds with 1 is going to be x. The side that corresponds with root 3 is going to be 5. And the side that corresponds with 2 is going to be y. So root 3 over 5, that's the one that we're going to go back to and use a couple of different times to set up our 2 problems. Our first one, we have root 3 over 5 equals, let's go ahead and solve for x first, 1 over x. And then our second one will be root 3 over 5 equals 2 over y. It's going to be the same math on both these. We're just going to cross multiply and solve, but the cross multiplication gets a little tricky here. We get x times root 3 equals 5. We'll go ahead and divide each side by the root 3. And then you get x equals 5 over root 3, which, like we said before, you have to rationalize the denominator. So we'll multiply the top and the bottom by root 3. And you're left with 5 root 3 over regular 3. So that's our answer for x. Now our answer for y on this one, we'll go back and do the exact same process. We have 2 times 5 is 10. You got root 3 times y, which is y root 3. Divide each side by the root 3. Those will cancel. And you're left with y equals 10 over root 3. Again, rationalize your denominator, multiply the top and the bottom by root 3. And your final answer will be 10 root 3 over 3. And you can't simplify the fractions on that, so we're just going to leave it as our final answer. Now, one thing to note on this, right? You guys were actually finding the short leg, which is your 1 in the pattern, and the hypotenuse, which is your 2 in the pattern. So what we could have actually done is the hypotenuse is always double the short leg. Right in your pattern, the short leg is a 1, the hypotenuse is a 2. So as soon as we did the math to find x, all we technically had to do, once we found x, is double our answer, and that would have given us y. So while you might look at all this and say, wow, that's a lot of work, we could have really cut the whole right-hand side of the problem off if we recognize that we knew the short leg and we're finding the hypotenuse. So those are little patterns that you guys will pick up on as you do these problems. All right, any questions you guys have, please bring them to class, and we will address them. Other than that, go ahead, keep taking good notes, and we'll see you guys in class.